Hello guys, my name is Lazaro and today we're going to be doing a medium LeetCode problem. This problem is called add two numbers 2. You're given two non-empty linked lists representing two non-negative integers. The most significant digit comes first and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except for the number 0 itself. Follow up. If you cannot modify the input lists, in other words, what if you cannot modify the input lists? In other words, reversing the lists is not allowed. So let's look at the first example. Here we have 7, then 7 points to 2, 2 points to 4, and 4 points to 3. This linked list right here represents 7,243. That's the number it represents. And then we're also given another linked list, which starts off at 5, and then 5 points to 6, and 6 points to 4. This represents the number 564. So if we were to take these two linked lists, turn them into numbers, and then add them together, we will get 7,807. Then we have to take that 7,807 and turn that into linked lists, where the head is the most significant number, and then that head points to the second most significant, which is why here it's 7,807. 4 plus 3 is 7, 6 plus 4 is 10, so there's a 0 right here, and we carry a 1. 5 plus 2 is 7, plus 1 is 8, and then 7 plus 0, because this number isn't that big, is just 7, and that's why we get it like this. Awesome. So now that we know how to read this problem, or how to take the inputs and how to create the output, let's get into the logic of it. All right. So we're given, So we're given the linked lists 7. Then from 7, we're going to be looking at 2. And then from 2, we're going to be looking at 4. And then from 4, we're going to be looking at 3. This is our first linked list. So this is linked list number 1. We're also given a second linked list, which starts off with 5. Then 5 points to 6. And then 6 points to 4. And then our output should be 7, and then 7 points to 8. And then 8 points to 0. And then 0 points to 7. So it's basically just adding these two linked lists together, just like that. Now, how do we want to handle this? Well, first off, the smart thing to do is to take this first linked list and let's turn that into a number. Since we know we start off at 7, and every other number is less significant, then we know is as we see more and more numbers, we want to push every number we've already seen to the left by 1. So for example, if we're starting off at 7, our count for, let's say we have a variable called count1, can just be 7 in the beginning. Then once we get to 2, that count, we multiply by 10. That's how we get the shifting left by 1. And then we add 2. That will give us 72. Then when we're at 4, we multiply by 10 again, shifting left one more time. That will give us 724. Finally, we also do the exact same step once we're looking at 3. And we get 7243. And then using that method, we can get the correct number, which is 7,243. Now, we can do the exact same thing for this second linked list. And we can use this to turn into a number. We start off by looking at 5. Our count is going to initially start off at 0. So 0 times 10 is just going to be 0, and then plus this 5 is going to be 5. Now that we're at 6, our count is now 5. So 5 times 10 is 50. 50 plus 6 is 56. When we're at 4, 56 times 10 is 560. And then plus 4, it's 564. So that's how we get the number 564. From there, all we really have to do is just sum these two numbers up. And we know that we get 7,807. Once we know this, we need to create a empty linked list. And inside that linked list, it needs to have this structure where every digit is a node that points to the next digit, the next less significant digit. We can do that by just taking the modulo of 10. This calculation will give us a number of 7. So this will be the remainder, because 10 can go into 7,800. But 10 is not enough to fit a 7. That'll be our leftover. But we know that this 7 actually represents the last 7 in the number, not the first one. So in our linked list, let me expand my canvas just a little bit. So in a linked list where it's initially empty, the next node is going to be 7. Now every time we take the modulo of 10, let's also divide this number by 10 to get 780. Because we took care of the 7 already, so now we want to take care of the next number, which will be a 0. And we can get rid of this 7 by just dividing by 10. And this is to give us a decimal point, so we want to floor it as well. Something to keep in mind. Let me. Okay. There we go. And then we have this 7. Now we take our new number and we do the exact same computation. This will now give us 0. Because 10 can go into 780. But there will be a remainder of 0. Well, which is no remainder at all, but you get the point. Now, what we want to do to add this to our linked list is that we want to make the next node 0. And then we want to make the next node of 0 our previous 7. So basically how we're doing this is we're storing in a temporary variable let's say this was answer. In a temporary variable, we're storing answer.next, which is equal to the node 7. Then what we're doing is we're overwriting what answer.next is equal to. We're making it equal to 0. And then we're taking that 0 and we're making the next of that 0 equal to the temporary variable, which aka this temporary variable variable here is just this seventh node. And then once again, we also want to divide by 10, do floor division, and now we get 78. So let's continue with this. Now we're at that 78, we still do the exact same thing. 78 modulo 10 is going to give us 8. 10 can go into 70, but 10 cannot go into 8. There'll be a remainder of just 8. And let me just write this now. This gives us 7, perfect. And now when adding to our node, we do that exact same logic like here. First, we hold that previous next into a temporary variable. So these two nodes are going to be in a temporary variable. And now we overwrite the next of this empty node and make that equal to 8. And then we set the next of 8 equal to this temporary variable, which is going to be 0 and then 0.27. And now finally, when we just have 7 modulo 10, 10 cannot go into 7, so there'll be a remainder of 7. 7 divided by 10, this will be 0. And then we do that exact same logic. And we end up with this linked list we have right here. And now when we return our answer, we want to return, let's say this was in a variable called ans. What we want to return is ans.next. And the reason why we're doing this is so we can get rid of this null node in the beginning. And it could just be this 7. Whoops, looks like I messed up. This should be a 0. And I wrote 8 again. There we go. Yeah, so this is exact same one like right here. So that's correct. And the reason we're doing ans.next is so we can get rid of this no node and just return this linked list. And that's the logic that we want for this problem. We take these two linked lists and turn them to an actual number by multiplying by 10 every single time and then adding the current value of the node. That multiplication of 10 is basically going to act as shifting left by 1. And then once we have both numbers, we just add them together and then we get the last number in the digit by taking the modulo of the sum. So we take the sum and get the modulo of 10. That's how we get the last digit. And then that last digit we add to our linked lists. Now we take our sum variable and divide it by 10, floor division. And then now we have a shorter number which excludes the one we just added to our linked list. And then we just keep on doing this, adding more and more to our linked lists until we get the answer. So how would this code look like? Well, let's write it out. Let's say we have two variables. We have num1, which is equal to 0, and then num2, which is equal to 0. First, we want to iterate over the first linked list. So, while the first linked list is not null, our num1 is going to equal to num1 times 10 plus the current value at the first linked list node. Then we want to iterate through the linked list. And this is how we get every single number in that linked list. So we take every single digit in the linked list and we put it all into just one number. This is how we do it. Now we're going to do something similar for the second linked list. So we're iterating over the second linked list. We want to multiply num2 by 10 just to do that shifting to the left by one digit. And then we're going to add the value of the node in the second linked list. And then let's get the next. Let's iterate through the second linked list. Now at this point, inside of num1, we will have the number of the first linked list, and inside of num2, we will have the number inside of the second linked list. So now let's get our sum. So our sum is just going to be num1 plus num2. And now our output, since our output has to be a linked list, let's just initialize an empty one. And now a little check that we want to do is, if our summed if it equals 0, then let's just return our answer, which is an empty linked list. Because if the sum of the two linked lists is just 0, then the answer is be a linked list of just 0 as well. Okay, now if it's not equal to 0, then our sum is a value. And we want to turn that value into a linked list. To do that, we want to iterate, and then while the summed is greater than 0, then we want to hold the next of our answer in a temporary variable. And then what we want to do is overwrite the next of answer and make it equal to a node that has summed, that is summed modulo 10. This right here is that last digit So this computation is the exact same one we did up here. That modulo 10 to get the last digit of our summed. So we want to add that to a node. And now, since answer.next is equal to that node, and we temporarily held its answer.next before we overrid it, now we want to add it. We want to add it back. And we do that by doing answer.next, and that's equal to 10. So let's do an example of this code block right here. Let's say our answer is equal to no 0. Well, actually, let me start like this. Let's say our summed was 407. And our answer is equal to no 0, 7. Now, we want to get this 4. And we could get that 4 by taking the modulo, because if this is our linked list, then remember, then we're also going to be divided by 10 every single time we add a node. So that's going to give us 40. And then 40 divided by 10 one more time is going to give us 4. And then 4 modulo 10 is just 4. So how do we add this 4 to answer now? Well, we take answer.next, which since this is the head right here, answer.next will be all of this. Let me expand this a little bit more. So answer.next is going to be equal to that. But now we're going to overwrite it. We're going to overwrite it and make answer.next equal to this 4, which is, so basically sum modulo 10 is going to be this calculation right here, and that's going to give us 4. So answer.next is now going to equal to 4. And remember, we held this previous answer.next in a temporary variable. Currently, now answer looks like this. But the number is 407, not just 4. So what we want to do is answer.next is equal to temp. And since temp here is this linked list, that means that after running this line right here, answer will now become 0. No is going to point to 4. And then 4 is going to point to temp, which is 0 and then 0.27. And that's how that works. All right. So hopefully that made sense. Now let me just delete this. Try to delete this as well. Okay. All right, perfect. So now that we have answer.next is equal to temp, and you guys understand what all this is doing, what we want to do is also floor summed by 10, divided by 10 and floor it. That is, if our sum was 407 and we added 7 to the linked list, then divided it by 10 and flooring it will now give us 40. Which makes sense, because now since we have 7 in our linked list, then we don't have 40. And we want to get this 0. Awesome. So after dividing it by 10, we actually finished with this whole while loop. This whole logic will build out that would take this summed variable, which is a number, and turn that into a linked list. After that, we just want to return answer dot next. And remember, the reason we're doing dot next is because the first node is null. So here, if this was answer, and we're calling dot next, what we're going to be returning is just this. Awesome. And that's actually all the code we need to write for this problem. Now let's see if this logic actually works. Okay, perfect. So let's create that num1 and num2 variables. And let's initialize both of them to be 0 and 0. Now let's iterate over the first linked list. And let's make num1 equal to num1 times 10 plus the value of the current node in L1. Then let's continue moving through L1 by just doing L1 is equal to L1 dot next. Now we're going to want to do something similar for the second linked list. By adding it to num2, and then let's also keep that moving. Now that we have both numbers built out, let's add them together. And let's also build out our answer variable, which is just like an empty list node. Now if summed is equal to 0, then let's just return answer. But if it's not, while summed is greater than 0, let's build out our linked lists. So let's store answer.next in a temporary variable, and let's set answer.next to equal to the current node to a new node that has a value of the last digit inside of summed. Then let's add that temporary variable back to the linked list, but instead of making it the next of the head node, we make it the next of the node of head.next, which here is answer.next. Now since we got the last number of our summed number, then since we got that last number, we added it to our linked list, let's remove it. Because since we already added it to our linked list, we no longer need it. Finally, after that, we can just return answer.next. Now let's run this code to see if I made any typos. I did not. Let's also submit it now. And it works perfect. So if you guys enjoyed this video and you enjoyed this problem, then I highly recommend that you join our Discord channel linked down below. We send out problems like this every single day for both beginner and advanced programmers. So if this interests you, then I really suggest that you join. Also, just to let you guys know that the time complexity of this algorithm is O of n, where n is the size of the larger linked list between L1 and L2. Also, the space complexity of this is going to be constant because we're not really adding to an array or anything like that. Other than that, I really hope you guys enjoyed. Thank you for watching and have a good day.